What is up, folks? It's Mr. Walker here coming to you with our notes for our properties of parallelograms. So, without further ado, let's get into it. Remember, a parallelogram is a quadrilateral with two sets of parallel lines. So, if a quadrilateral is a parallelogram, then it has opposite sides that are congruent as well. So, the top and the bottom, the left and the right here, they are congruent as well as parallel. Next one, if a quadrilateral is a parallelogram, then its opposite angles are also congruent. So, not only are these opposite sides in this shape congruent, the opposite angles are also congruent. Remember when we think of opposite, opposite means that we're not touching. So this is not touching this. That makes them opposite. This angle is not touching this angle. So they are also opposite. So that'll let you know that these guys are congruent. Not everything, but just the ones that are opposite each other. Now, following up with those, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Remember when we talked about parallel lines way back at the beginning of the year? If this line up top and this line on the bottom are parallel, then the angles that are consecutive and in between them add up to 180, making them supplementary. Same thing with these two. They add up to 180. That means this top and this bottom line are supplementary. Likewise, these two angles also add up to 180, which makes this and this line also parallel and making these angles supplementary. So keep that stuff in mind as we go through. Finally, if a quadrilateral is a parallelogram, then its diagonals bisect each other. When we say a diagonal line, I'm talking about a line that goes from one corner, one vertex, to a vertex it's not touching. So this line here is a diagonal line. If we went from one corner to the next one, then that would make this just a side as opposed to a diagonal line. So remember, diagonals cross somewhere inside of the shape to the next non-adjacent corner. Okay? So these are all for any parallelogram, but if you remember from our last lesson, our parallelogram has quite a big family tree that we got to talk about. Now, all of these shapes are parallelograms, so let's go through and talk about our first one, the rectangle. A rectangle has two sets of parallel lines. Our opposite angles and opposite sides are congruent. And we have four right angles in here. Our diagonals in this shape are going to be congruent and they bisect each other. So the diagonals in this shape not only bisect each other, they're also congruent. And all of our angles are right angles. Next one in our family tree we're talking about is a rhombus. A rhombus has two sets of parallel sides because it's a parallelogram. All four sides in this shape are congruent. So it's not like a rectangle. All of the sides are congruent. In this, the opposite angles are congruent. So the ones that aren't touching each other, they are the same size. The diagonals bisect the opposite angle in this shape. So that means that if I see a diagonal, it will bisect that angle opposite it. And then finally, our diagonals are going to be perpendicular to each other. So those two both come in hand for this kind of shape. Now, if you remember our family tree that we talked about with parallelograms, these two guys have someone in common. A little kid down here called the square. A square is just like a parallelogram as well as these two. So that means that it's going to share a lot of these characteristics. It has two sets of parallel lines like both of these guys have. This will have four congruent sides just like the rhombus. It has four right angles like our rectangle. Our diagonals are congruent like our rectangle. The diagonals are also perpendicular and they bisect each other, just like the rhombus in our parallelogram. And our diagonals bisect the right angles, just like how the rhombus has diagonals that bisect each other. So that's our family tree in full detail. And you already know how this is. We're going to get into some algebra with our practice. So if you want to pause it, and use our theorems to bring this up and try them, go ahead and do that. All right, folks, so I hope that you're back and you took some time to try these out for yourself. Let's get into it. So, first thing we got a parallelogram here, we got a parallelogram there, we got a parallelogram everywhere. They ask us to find the values of x and y that make these guys parallelograms. We got to add one thing right here. This is a y down here because it didn't show up. Sorry about that. So, if this is going to be a parallelogram, we got to go back to our beginning theorems. Let's go through and talk about this first one. In a parallelogram, the opposite sides of this are congruent. So that means that for our first example, we're going to do a little bit of marking. This side here and this side here are opposite. They're congruent. This side up top and this side on the bottom are opposite each other and also are congruent. So let's set this up and knock it down, people. We got 3x plus 7 is equal to 6x minus 14. I want to go through and get my constants on one side, my variables on the other. So I added the 14 to the other side. I subtracted the 3x to the other side. And when I divide both sides by 3, I ended up with x is equal to 7. Now, just like this, our opposite sides are congruent once again. So 4y plus 7 is equal to 8y minus 9. I continue to solve. I bring my y's to one side, my constants to the other side, giving me 4y is equal to 16. And when I divide both sides by 4, I get y is equal to 4. All right, next one. We don't got sides here, but we got angles. So let's go refer back to our theorem for some angles. In this, it tells us that in a parallelogram, the opposite angles are congruent and the consecutive angles are supplementary. So, taking a look back at our work here, I got two opposite angles. So that means that these two here are both going to be equal to each other. And I also know that this and this, these guys are consecutive, which means that these two add up to 180. I'm going to need to go through this 180 to figure out what x is, because I don't want to set that equation up with a y is equal to x because I don't know what both of those are yet. So let's solve this. I combine my like terms. That gives me 12x minus 18. I add the 18 over, and then I divide by 12. So when I add the 18 over, I get 198, and when I divide that by 12, I get 16 and a half. Now, that's what x is. So if I want to figure out what these two equal angles are, I'm going to plug that back into that equation with that x. So I got 8 times 16.5 minus 10. When I calculate that, I end up getting a 122. And now that I know that it's 122, I could set these equal to 122. So 5y minus 6 is equal to 122. I divide after I add that 6, and that gets me a 23.2. So, same type of deal as we've done in the past. We just have to use the context from our theorems so that we can solve some stuff. All right, next one we got here. We got a set of angles here. I want to figure out what x is here, and I want to figure out what y is here. Remember, this is a parallelogram, so that means that the top and the bottom lines here are parallel as well as the left and the right sides. And because these angles are inside of them, I know that this and this, these two angles, this 60 and this big angle, add up to our old friend 180. So for me to figure out what that x is, I'm going to subtract 60 from 180. That's going to tell me that this big angle right here, this is 120. Now that's 120. I know that if I subtract that 52 from 120, that's going to tell me that that x value there is 68. Now, along with this being a parallelogram, it's a set of parallel lines, so our theorems from that can come into play here. These two angles, 52 and this y up here, are alternate interior angles. You may not remember this, but it's been a while since we've used this. Alternate interior angles are congruent. So that means that y up there is also that 52 down there. So we can use a lot of the different theorems that we've gone through and dealt with this year to make it nice and easy and a little bit clearer. All right, final one that we got here. We got two diagonal lines. So let's go back to what diagonals do inside of a parallelogram. The diagonals in a parallelogram bisect each other. So that's our final theorem that we're going to use. So if these guys bisect each other, that means that this side and this side are the same, and this side are also the same. So there's quite a bit of things that we're going to want to go through to do. We're going to take a little shortcut. Since y is equal to x plus 2, I could substitute any y that I see in here with x plus 2, so I could figure out what x is at least. Once I figure out what x is, I can spin it back and figure out what y is. So I got x plus 10 is equal to, instead of 2y minus 8, 2 parentheses x plus 2 is minus by 8. I combine my like terms after I continue to distribute here. So I combine the like terms and I solved that x was 14. And then, because I know what x is, I can go through and plug that back into the other side. Y was equal to x plus 2, which is 14 plus 2, which is 16. All right, people. We went through and handled this. If you were feeling any type of way, you need to make sure that you practice and write down the stuff. It's not enough to just say and say you could just do it in your head. You got to do it on the paper. I will catch y'all later.